This video goes over the quadratic function as well as vertical translations and horizontal translations. So the first thing that we're going to do is graph y equals x squared, which is also called a parent function. And then we're going to look at how we can shift that parent function to represent other situations. So the first thing we're going to do is use a table of values to graph y equals x squared. So I'm going to start with some negative values, and I'm going to go all the way up to positive 3. Remember, to find my y coordinate, all I'm going to do is square the number because of what the function tells me. So I know that y is equal to x squared. X in my first case is minus 3, so the corresponding y point of that must be minus 3 squared, which is 9. I can continue going all the way down, squaring my x coordinate, and that's going to give me a series of 7 points that I'm now going to plot on my graph. So I've got 0, 0, minus 1, 1, minus 2, 4, minus 3, 9, 1, 1, 2, 4, and 3, 9 here. And then I'm going to connect these so they look like a parabola or a bowl shape. And then I'm going to label my graph. This is the parent function. This is what the base parabola looks like. So we've got two names for a degree 2 function, a quadratic or a parabola. The equation always has an x squared in it, and the graph passes the vertical line test. What that means is that if I were to draw a series of vertical lines through my parabola, as I'm doing right now, that at each point, each vertical line would only cross my graph once. To quickly draw a parabola, we can find a pattern between the points. If we start at 0, 0, we can plot points to the right by using the pattern over 1, up 1, over 1, up 3, and then over 1, up 5. Okay, over 1, up 1, over 1, up 3, over 1, up 5. Similarly, on the left, we can go left 1, up 1, left 1, up 3, and then left 1, up 5. That's going to give us our base pattern and our base point, so we can plot the parabola very quickly. There are a couple terms that you need to be familiar with when it comes to talking about the quadratic function. The first one is an axis of symmetry, which is a reflection line that maps a parabola onto itself. So if I draw a parabola that is centered right here, my axis of symmetry is going to be the line that goes through right through the middle, has the equation x equals a. The vertex is going to be the point of intersection of the parabola and the axis of symmetry. So that's right here, the vertex, and I'm just going to change this. I'm going to call the axis of symmetry x equals h, and the vertex, I'm going to use the coordinates h and k. The vertex is also the point where the parabola changes direction, and it's the highest or lowest point of the parabola. The third property that you should be familiar with is the direction of opening, whether it opens up or down. And then finally, the maximum or minimum value. So that's the y value of the vertex, or k. It's a maximum if your parabola opens down, and it's a minimum if the parabola opens up. So let's do a couple of examples. Here we're going to graph the following using a table of values. So I'm going to start the same way I did my first example, going from minus 3 to positive 3. Now this one, my y coordinate is slightly different. I'm going to square my x coordinate and then add 3. So 3 squared is 9, plus 3 is 12. Minus 2 squared is 4, plus 3 is 7. Minus 1 squared is 1, plus 3 is 4. 0 squared plus 3, 4, 7, and then 12. So now I'm going to plot my points over here. So I've got 0, 3, minus 1, 4, minus 2, 7, minus 3, 12, and then the same on the other side. So I've got the same parabola I had at the beginning, just shifted up by 3. So my axis of symmetry is going to be the line that goes right through the center of the parabola. So I'm going to draw it here in red. And this is going to be my axis of symmetry. So my axis of symmetry is a vertical line. So it has the equation x equals 0 in this case, because all of the coordinates on that line have the coordinate x equals 0. My vertex is this point right here, 0, 3. My direction of opening is up, and my minimum or max is going to be the y value of my vertex. So it is a minimum because my parabola opens up, and the value is 3. Mathematically, anytime you see an equation y equals x squared plus k, as in this one we had plus 3, it's a vertical translation of k up or down. So we've got the axis of symmetry is going to stay the same in a vertical transformation. Okay. The vertex is going to be 0 and 0 plus k. Your direction of opening is going to stay the same. And then your minimum and maximum is going to stay the same. So so this is going to erase here. So let's say whether your graph is a minimum or a maximum stays the same, but your value is going to change by y plus k or y minus k. Y equals x squared plus 7 and y equals x squared minus 4 without using a table of values. I'm going to start with my base parabola, y equals x squared, where I know that my vertex is 0, 0, and my point pattern is 1, 3, 5. So over 1, up 1, over 1, up 3, over 1, up 5. For my first parabola, y equals x squared plus 7, I know I have a vertical shift. So that means that my new parabola is going to be 0, 7, and I would keep the same point pattern. Over 1, up 1, over 3, up 5. My other characteristics have stayed the same. My maximum value is now going to be, or my minimum value is now going to be 7 instead of 0. For my second parabola, I've got y equals x squared minus 4. My vertex is now going to be 0, minus 4, and my point pattern is going to stay the same. My direction of opening is still up, that stays the same, and now my minimum value, instead of being 0, would now be negative 4. The next example that I'm going to look at is graphing another parabola using a table of values. This one looks a little bit different. We're still going to start the same way, from minus 3 to 3. Now what I'm doing is I'm taking 1 away from the x coordinate and then squaring the result. So minus 3 minus 1 minus 4 squared is 16. Minus 2 minus 1 is minus 3 squared is 9. Minus 1 is 2, squared is 4. 1, 0, 1, 4. So that's going to give me some information to plot here. Minus 3, 16, I'm not going to plot because it doesn't land on my grid. I am going to do minus 2, 9. Minus 1, 4. 0, 1. 1, 0, 2, 1, and 3, and 4. You should notice a difference here from our original parabola. Either from the parabola that we did in the first example or our standard parabola here. So what I'm going to do, got one extra point here. You can imagine that it also continues on the right-hand side. So now what I'm going to identify is my key characteristics. So my first one is the axis of symmetry. So for the axis of symmetry, I'm going to draw a line right through my vertex here. Vertical line always. And I'm going to label that with the equation of the x-coordinate that it passes through. So in this case, x equals 1. I'm also going to label my vertex, which is this point of the parabola. Those coordinates are 1, 0. My direction of opening is up. I have a minimum value, and my minimum value is 0. And so what we have here is a horizontal translation of 8 h units to the left or to the right. Now you should notice that in our example here we had x minus 1 and we shifted our base parabola to the right. So our axis of symmetry is going to be shifted h units, so left or right. Okay. My vertex is going to be x minus h, and then k still stays the same, which in our case we can just leave as a 0. Our direction of opening stays the same, and our minimum or maximum value and the value that is also going to stay the same. So what we can look at is how we would graph y equals x plus 3 squared and y equals x minus 1 squared without using a table of values. So we're going to start always with our parent function, y equals x squared, where our vertex is 0, 0. So our first equation, y equals x plus 3 squared, we would have a horizontal shift 3 units to the left. Okay, so that means that our new vertex is going to be minus 3, 0. Our new axis of symmetry would be x equals minus 3, and everything else is going to remain the same. Our point pattern is still the same too, so we can easily graph it after we have the vertex. Our second example here, y equals x minus 1 squared, is a horizontal shift 1 unit to the right. So that means that our new vertex is going to be 1, 0, as we showed in our example above, and our new axis of symmetry would be x equals 1. Those are examples of the base quadratic function, a vertical translation, and a horizontal translation.